Remember, to expand and simplify, we're going to distribute the leading term into the brackets. We're going to take that x and we're going to sprinkle it in. So remember that means x times x and x times -1. So x times x and x times +1. X times x, x squared, and x times +1 is +1x. I don't need to show the 1. So just remembering, expand is how we distribute, or it tells us to distribute, simplify, put like terms together. If it doesn't say simplify, we still want to all the time. 2x squared times x is 2x cubed. 2x squared times -3 is -6x squared. So that's expanding, going forward when we distribute in. Today we're going to do the opposite action, going the other way, and we're going to be pulling it out. We're going to find something that we can pull out and put in front to get back to the expand and simplify, or back into factored form. So factoring is the inverse, or the opposite operation of expand and simplify. So, factor fully. We want to find a common factor. A common factor is something that can be divided by, that each term can be divided by, or can be pulled out of each term. So for 6x and 3, 3 is our common factor. And I'll draw it like this. 3 is our common factor. So what we're doing is, we're going to do 6x divided by 3, which gives us 2x, and 3 divided by 3, which gives us 1. Because we chose that 3 to divide it by, that 3 goes in front. So I'm really saying divide by 3, which we did here, gives me 2x plus 1, and because I divided by 3, that 3 goes in front. So let's try it here. 8x and -4. I'm looking for a common factor. What number can go into both 8 and 4? And I want the biggest one possible, and I'm going to say that is 4. So by showing it that way, I'm saying that I am factoring out 4, or I'm dividing each term by 4. So that 4 doesn't disappear, it goes in front. And I'm really saying 8x divided by that 4, 8x divided by 4 is 2x, and -4 divided by 4 is -1. Because I divided 4 out, I need to show that I've pulled it out, and so I add the brackets with what's remaining. 8x divided by 4 gives me 2x, and -4 divided by 4 gives me -1. And of course I lead with equals. So I want to factor fully. Start with my equal sign. I look for the biggest number that can go into 4x squared and -20, and the biggest number again is 4. So that 4 doesn't disappear, it goes in front. I start a bracket and I say 4x squared divided by 4 is 1x squared. I just need to show x squared. I don't need to write my coefficient of 1. -20 divided by 4 is -5. Done. Now, if for some reason I didn't notice the biggest number possible was 4, let's just do a second time. If I look and they're both even, and I said, oh, I can divide each of them by 2 because they're even, I just start the process. 4x squared divided by 2 gives me 2x squared. -20 divided by 2 gives me -10. If I then peeked and said, wait a minute, I can go further because both of those are even again, so I could divide by 2 again. That 2 gets out of the brackets. This green 2, the first factor that I took out of 2, is still there. And now I do the same thing again. 2x squared divided by 2 is 1x squared. -10 divided by 2 is negative 5. The only difference here being that 2 times 2 is 4. Because they're both numbers, I can multiply them together, and I get to the same result. That's if I don't notice, or I didn't notice, the biggest common factor to begin with. I can continue to work. It doesn't affect me. It's not that big a deal. If we try another one, if there's a negative leading the first term, I might choose to factor out a negative number. In this case, negative 2 and 8, they're both even. 2 is the biggest number that can go into each of them, so that goes in front. Negative 2x divided by negative 2 is positive 1x. 8 divided by negative 2 is negative 4. Done. Now at the same time, I can factor out more than just numbers. The greatest common factor can also be variables and exponents, or multiple variables. So if we look at this situation, the biggest common factor in terms of number for 25 and negative 15 is 5. So that 5 goes in front. Now, just as a reminder, x exponent 6 means 1, 2, 3, 4, 5, 6 x's times each other. X times x times x times x times x times x. And x exponent 4 means x times x times x times x. So really, this term, 5x to the power of 6, has 6 x's. Negative 3x to the power of 4 has 4 x's. So I can take out 4 x's, or I can divide by 4 x's for each of them, and that's why I have x exponent 4 in front as well. So we can do number as well as variables. So if I look at 30, x exponent 3 minus 42, x exponent 4, those are both multiples of 6. So I can take out 6. That 6 goes in front. And then if I look and say, ooh, x exponent 3, x exponent 8, they each have at least 3. So I'm going to take out x to the exponent 3. Now 30 divided by 6 gives me 5. X exponent 3 divided by x exponent 3. Remembering that x exponent 3 divided by x exponent 3 really means 3 minus 3, which is x exponent 0. Anything exponent 0 is equal to 1. So 5 times 1 is 5. 42 divided by 6 is 7, and it's a negative. So negative 42 divided by 6 is negative 7. X exponent 8 divided by x exponent 3 really is 8 minus 3, which is x exponent 5. And I've gone as far as I need to. Fully factored. There's no more common factor I can divide by or pull out of the brackets. If I look at my next example of everything together, in terms of number, 3 and 1, I'm just going to take out a 1. I don't really need to show that. But always thinking that the number could be 1, and then if I look at my variables, there's 6 x's there, and there's 2 of them there, multiplied in a row, so I can take out 2 from each of them. I guess that should be in blue. So that x squared goes in front, and what remains goes in the brackets. 3x exponent 6 divided by x squared is 3x exponent 4. 6 take away 2 is 4. X squared divided by x squared is x exponent 0, which is 1. Or x squared divided by x squared is 1. And I've gone as far as I can. That is common factoring. Whenever we start to factor from now on, we're always going to look to common factor first. That's always going to be our first step. We've done factoring simple trinomials where our a value is 1. But from now on, we're going to look for a common factor first.